that we usually call U-Substitution. To make a change of variables, usually we're looking at this, we're always looking at this situation right here where we have f evaluated at a function of g times g prime. Now, if we can rewrite this as the integral of f of a function u times du, then this is just the antiderivative evaluated at u plus c. And of course, we're going to need to take this back to x. So to do these problems, what you want to do is find a substitution for u. And it's usually the inside part of your function, the inside of something to a power or the inside of a trig function. And then you find du, which is g prime dx. And then you rewrite the entire integral in terms of u, integrate with respect to u, and then substitute back. Anywhere you have a u, go back and put it back in terms of x. And then you can check your answer by differentiating. So let's look at this function right here. Suppose I have the integral of 2 square root of 2x minus 1. You're going to want u to be what's inside. And for this, I need you to actually write u equals 2x minus 1. Then find du. du is 2 dx. Now, I need to substitute u and dx back into my equation. So I'm going to take this equation right here and solve this. dx is du divided by 2. And now I'm going to plug these in. I'm going to take this right here and plug it in, and then this right here, the dx, and plug it in. And when I do, this becomes the integral of u to the 1/2. Now when I plug in dx, that's going to be du divided by 2. So I'm going to rewrite this as 1/2 the integral of u to the 1/2 du, which is 1/2 u to the 3/2 divided by 3/2 plus c. I'm going to simplify this before I move any further. This becomes 1/3 u to the 3/2 plus c. Now, I need to change this all back to x. So now I'm going to take du. Not du, I'm going to take u again, and everywhere I have a u down here, I'm going to replace it with 2x minus 1. So my integral becomes 1/3 times 2x minus 1 to the 3/2 plus c. Now I can check this. If I take the derivative of this, what am I going to get? If I take the derivative of this, it's going to be 1/3 times 3/2 times 2x minus 1. I'll lower the power by 1, so it comes down to 1/2, times the derivative of what's inside, which is 2. So the 3 cancels, the 2 cancels, and I'm left with 2x minus 1 to the 1/2, which is indeed what I started with. Now, sometimes changing variables is a little bit more work. Let's look at this function right here. Remember I told you, set this equal to u. So let u equal 2x minus 1, and then du is 2 dx. That's all fine, good, and well, but I've got this extra x out here. When you have a situation like this, and this is a really common trick, then what you need to do is come back here and solve this for x. All right, and if I solve this for x, then I see that x is equal to u plus 1 over 2. So now I'm going to plug everything back into my integral. So this becomes the integral. X is u plus 1 over 2 times the square root of 2x minus 1. So this is u to the 1/2. And I need to solve this for dx. So dx is du over 2. skipped a step there, or tried to. So this is du over 2. Now let me rewrite this. This becomes 1/4. I'm just going to factor that fourth out of there. The integral of, let's see, this is going to be u to the 3/2 plus u to the 1/2 times du. Now this is something I can integrate. So this is 1/4 times u to the 5/2 divided by 5/2 plus u to the 3/2 divided by 3/2 plus c. All right, now I'm going to rewrite this again. If I can see I'm going to have a little bit of canceling here. I'm going to go back and plug in u as 2x minus 1 and then work out my fractions here. So this is going to be 2x minus 1 to the 5/2. And this is going to be over 5 over 2. So this is going to be 1/10 plus, let's see, this is 2x minus 1 to the 3/2. It's going to be over 3 over 2. So that's plus 1/6 plus c. In this case right here, sometimes you have trig functions. Now for this one, if I let u, this one's kind of a little bit more work. For this one, I want to let u equal sine of x. Excuse me, sine of 3x. Then du is derivative of sine is cosine of 3x. Now I have to take the derivative of what's inside, so this is 3 dx. So I'm going to solve this for cosine 3x dx, because that's what I have right here, and that's equal to du divided by 3. So when I rewrite this integral, it becomes the integral of u squared du over 3. So this is u cubed over 9 plus c. Plug back in sine 3x quantity cubed over 9 plus c.